Yeah. So, good morning. In today's session, we are going to discuss about a special data structure called stack data structure. Okay, stack data structure in Python. So, how we can able to implement this stack data structure with the help of examples and what are its applications. So, some applications we will develop, sir. Okay, this is our today's main agenda. Okay, stack implementation. Sir, first let me talk about introduction. Let us go for introduction of this particular stack. Like what is mean by stack? Okay, so what is the technique that is followed in the stack that we will discuss. See, coming to this introduction, I can say a stack is linear data structure. A stack is nothing but linear data structure. What is the meaning of this? The memory allocation. The memory allocation for objects are continuous memory locations. Continuous memory locations. So if you take any object, that object, next object will be stored in the immediate memory location. This is nothing but this particular stack data structure is going to use. And this stack data structure follows one special technique. That technique is nothing but last in, first out. What is the meaning of this short form? LIFO. So our stack is going to follow LIFO methodology or LIFO technique. Means what? The item which we are inserting the last is the item which we are going to remove first. This is the technique which is followed in this particular stack. Okay. So I will take directly examples where we can able to use this stack. So first example, I can say a stack of plates, a stack of plates. For example, if you take any buffet system or anywhere, if you see, so they are going to arrange the plates in this order. Okay, first plate will be there, second plate, third plate, fourth plate, fifth plate, like this. So which plate you are going to select first? The plate which they have kept at the top is the plate that you have to remove. Have you observed? Last inserted object we are extracting first. That's why it is called as LIFO principle. Even we can able to say, so disks, okay, disks in the rack. So if you say any disk, okay, so that disk will be organized, disks will be organized in the form of a stack only. Okay. So next and after that, especially our function calls in Python, not only in Python, in any programming language, function calls are stored. Function calls are stored inside stack. Okay. So suppose consider I have a small function is there like this. Okay. I have a function is there like a function is there. So inside this function A, so I'm executing some instructions and I'm calling B, and I have few more instructions are there. So B function is there. It is executing one instruction and it is calling C, and C function is there. It is executing some instructions. That's all. Now, how it is going to be called? First, a stack will be maintained. We are calling A. So first it will execute these two instructions. Then we are calling B. That method call will be stored inside the stack. Then control will go here and it will execute the instructions present here. And again, we are calling the method C. Then what will happen? The control will go here. It will execute all the instructions. And now the control will come back to the original function. So the entry will be removed from the stack and it will execute this instruction. After that, again, the control will come to the original position and B entry will be removed from the stack and it will execute these two instructions. Like to maintain the statistics, the control flow of functions, we are going to use which data structure? Stack. Of course, we are not using internally. This particular system is using these particular method calls. See, all the function calls or method calls will be stored inside the stack. So next and after that, for example, if you see URLs, okay. So suppose web page navigations also are used internally implemented by using stack only. For example, if you see I'm going to visit one website. Okay, so that website is taking control to another website. Okay, that website is taking control to another website, something like function calls. Sir, how it is going to be maintained? So inside the stack only they are going to maintain. If you click on next previous button, I mean back button in the websites, you can see there will be a back button. If you press, then what will happen? So the last visited website you are going to get. Okay, this is nothing but one of the application of stack. So next and after that, even parenthesis balancing, we are using stack data structure. Okay, and even if anywhere reversing the items, sir, I want to reverse a number, then what we have to do? Already we have seen that in the recursion. So whenever we are if you want to print the data, so first we will print the value of I, and then we will call a function by passing I plus 1. So again, we can print the value of I. At very beginning, what will happen? We are getting 1, 2, 3. So whenever we are calling these, it will maintain a stack. First one will be pushed, then two will be pushed, then three will be pushed. So second time after this recursion call, if you are writing any statement, then it is going to extract in the reverse direction. So wherever reverse operation is required, so in all such cases, we have to go for this stack data structure. So even infix to or in expression evaluation, infix to so prefix conversion, infix to postfix conversion, we can use this stack data structure. Okay, and even evaluation of prefix or postfix. Sir, I want to evaluate a prefix or postfix. There also we are going to use this data structure. Sir, undo operation, redo operation. Okay, or I can say forward direction, or backward direction. In these cases, we are going to use which data structure? Stack data structure. This is nothing but what we have. I think the introduction to the stack is very clear for you people, right? Any doubts up to this? Please confirm everyone.
Sir, can you explain the function calls one?
What's our function calls?
Yes. Function
See,
calls are
suppose
stored
if
in
you
stack.
take a function fun1 is there, it is having some instructions, like two instructions are there. Consider this is A and it is nothing but B. So then again I am calling another function called fun2. So after that I am taking two more statements like C and then D. And here we are taking another function called fun2. So here I am going to print the message like E, and after this I am calling another function called 3. And after this I am printing some statement called F. Then function 3 is there, it is printing some message called G. So what is the output of this particular program? If you see, so it will maintain internally a stack. First we are calling function 1, that function 1 entry will be stored inside the stack. Okay, then what we are going to do? It will print A and it will print B. So after completion of this, we are transferring the control to function 2. So the control will go here and it will execute E. Because we called function 2, corresponding entry will be there in the stack. So we called this E, I mean function 2, it is executing E. After that, the function it is calling 3. So immediately what will happen? Function 3 is going to execute and it will print the message called G. After this, the control will come back to the previous call. How it is going to identify the previous call? Function 3 execution completed. Function 2, it is going to come. In the function 2, one of the instruction is pending. So that will be printed here. So after that, what will happen? So there is no more instructions. Again, it will call to the previous method call. So how it is going to recognize that from function 2, it has to come to the function 1, because that method flow of control will be maintained inside the stack. Now, what is output? These two instructions are going to be executed. This is nothing but output for this functions program by using these three functions. Internally, these method calls, function calls will be maintained. So inside stack, I think in the recursion, we have seen very clearly, sir. So I request everyone to please confirm, is the concept is clear?
Yes, sir. Clear.
I request everyone to
Yes,
please
sir.
confirm.
Yes,
Sir, stack is maintained for each program or each function.
Wherever you are using function, so there it is going to maintain stack, not for program. It is maintained for functions.
Now we have 4 function, right? Function 1, function 2, function 3. Okay, 3 function is there. So
Hmm.
each function have a stack.
No, why? For that, see here these function calls, see whenever we have a function 1, so it will maintain a stack. Inside that function 1 will be stored. If it is calling another function, then only the control is moving, right? So there it is going to maintain another function call here. So that function calls alone, it will maintain inside the stack, sir. So program is not responsible to create the stack. Suppose in your program, if you have only one function, so stack will be created with only one function in the stack, and it will be destroyed automatically. So we can't give guarantee, but so whenever functional programming is there, it will maintain a stack. That is internal activity, sir. We are not required to put more concentration on that. Okay.
Means it's provided by OS, right?
It's
Stack is
provided by language.
language.
Yeah, that memory allocation will be given by that is called as operating system only. But the programming language is responsible for creating and deleting.
Okay, sir. Okay, that's fine. Thank you,
recursion
sir.
and backtracking are also application, right?
Yeah, backtracking also we are going to use this.
Sir, in object-oriented, in methods also
Yes,
creating stack.
everywhere. Yeah, everywhere functions and methods will be maintained inside the stack only.
Okay.
Okay. Sir, please
The
confirm everyone.
constructor is also method, sir. Special method. Okay, okay.
Right, I request everyone to please confirm is the concept is clear up to this so that we can go for the next one.
Yes, sir. Yes, sir. Clear.
Clear,
Yes,
sir.
sir. Clear, sir.
Right. So coming to the next one. So operations that can be performed on stack. What are the common operations that we can able to perform on stack? See, the following are the sum of operations, so that can be performed on stack. So what operations we can able to do? The first operation is nothing but a push. So what is the meaning of this push? Is nothing but inserting an object into stack. Suppose if I have any object is there, inserting that object into the stack, that operation is called as a push operation. And one more operation is called as a pop. Pop means what? So deleting. So deleting an object from stack is called as pop operation. And we have one more operation is there called peek. Peek means so returning the topmost object in the stack. So I can say topmost in the sense which is ready to give access. Okay, then so we have one more method is there called the size. So what is the purpose of this size? It returns a number of elements, number of objects in the stack. How many objects are there, it will return. Similarly, isEmpty function is there. What is the purpose of this isEmpty? It returns true if the stack is empty. So else it is going to return false. Like this we have. And we have one more method is there. That method is nothing but, do you know, traversing, display. So it display, or it is going to traverse so elements in the stack. Okay, so what are the elements are there in the stack, it is going to display. These are nothing but very common operations that we are going to perform. And if you see, whenever here we are going to maintain one special variable. Okay, so if implementation of stack, if I want to implement a stack, so we need two elements must be required. One is nothing but an array or list, anything. Okay, so we have to maintain a container, and we have to maintain one special pointer called a top. Top is nothing but a pointer. So when an element or when an object is inserted, so top will be incremented. Top will be incremented by 1 unit. And when an item or when object is deleted, so top will be decremented by 1 unit. So this is nothing but what we have, sir. Any doubt on these common operations and how we are going to implement the basic idea? Is it clear, right?
Yes.
Yes, sir.
Yes, sir.
Right. So how we can able to implement this stack data structure? So there are various ways are there for implementing this stack. Okay, we have various ways are there for implementing this stack. How to implement in Python? We can see the first way is nothing but using list. Already we have list is there, right? By using that list also we can implement a stack. And even in Python we have collections module is there. In this collections module, tq is there. By using this also we can implement a stack. Then third way, by using our own, okay, by using our own methods, by using our own implementation also we can able to implement this stack. There are three ways are there. Okay, so one by one I will explain. By using stack, I mean by using list, how I am going to take. So by using collections module, how you can able to implement, like one by one we are going to see. So first I will take by using a list, how I am going to implement this stack implementation. Stack implementation by using list. Already we have list is there, right? By using this list we can able to do. Suppose consider I have a list is there, something like this. So if you print list, what is the output that we are going to get? Empty objects are there, simply it is going to print. So now my operation is nothing but I want to store this item. I want to push one item into this stack. Then what we have to do? Try to use append function, sir. If you push triple one, and if you are trying to push triple two, and if you are trying to push triple three, and if you are trying to push triple four, and if you are trying to push triple five, so how it is going to be added? So since we are performing addition operation, at the end always the elements will be stored inside this stack in this format. Of course here we are not creating any stack, we are taking the concept of list. So to maintain this stack like this, it will be maintained. What is the first object that we are going to get here? Triple one is the first object. What is the second object that we have? Triple two is nothing but the second object. So what is the third object that we have? Triple three is the third object. What is the next object that we have? So triple four is nothing but the next object. What is the next object that we have? So triple five is the next object. Like this we have. So I can say this is nothing but a stack. So where top pointer will be maintained, top is always pointing at this. So now I want to get the element which is available at the top. So we can able to call like this L of -1. So which is going to return always the topmost element present in the stack. So which element is present at the top, sir? You can able to see triple five is the element which is available in the stack at very top. So now let us execute this code. You can see these are the stack elements, and triple five is nothing but the topmost element which is available. Okay. Now if you want, you can access the last, I mean I want to delete the last element. How to delete? So just try to use L dot pop, that's all. Automatically it is going to remove the last element present in the stack. You can see that triple five is gone or not? Yes. So automatically this entry is going to be deleted from the stack. If you perform one more time pop operation, then which object is going to be deleted? Triple four is going to be deleted. So here we have not at all implemented anything. Okay, so we can check whether my stack is empty or not. How you can check? Sir, is len of list is double equal to 0? I will ask. Sir, what will happen? My output is nothing but false. That means my list is not, I mean, my stack is not empty. Like this, we can able to find out. Sir, I want the length of the list. So which is nothing but the number of elements present in the stack or not? Yes. See here, no new concept we introduced. We have taken the list, but in that list, we are using some special functions to insert the objects and to remove the objects. And those functions, I mean, those methods we are using appropriately such that the implementation should become stack. So because in the case of stack, insertions and deletions are performed at only one end. That's why I am taking this particular concept. Can you please confirm how we implemented this stack by using list concept? Is it is clear for you people all the operations?
Yes, sir. It's clear.
Clear. So, but we also remove the element at first or second or third.
No, we are not doing that. If you do that, then it won't be a stack.
Sir, one by one we can delete. Now 555 is deleted after 444. After
Yes, if you
triple,
call pop one more time, it will delete 444. See,
randomly
no,
as we were deleting the node at any point, so we are not able to delete this one, means in the stack. Is suppose
in the stack we should not delete at any position.
okay, sir, got it.
But in the list we can do. Actually, here also we can delete at any position, but we want to do that. If you do that, then it is not a stack. So we have to insert
Okay, sir.
always at the ending, and we have to delete always from the ending. This is nothing but a stack. Sir, I request everyone to please confirm. Is the concept is clear up to this?
Yes,
Yes, sir.
Yes, sir.
Sir, here we need to put one condition as well, because if a stack is empty, then it will raise an error, an index error, element not found, like error we will get at that.
Yeah. We can write that, but just for understanding purpose, I'm telling. Actually, we won't go for these kind of things, right? Generally.
Oh, okay.
So because our list will act as a stack, that's that point I'm trying to explain.
Oh, okay. Okay, sir.
So we
Please.
need to write the functions like how we have done in the linked list. Like this, we have to write the functions.
Okay. Okay, sir. Clear, sir.
Yeah, in the last, we will see how we are going to write that. Right. So now the second one, sir, first one we understood very clearly. The second one is nothing but we can implement the stack by using collections.dq. Okay, we have collections is there, right? Stack implementation by using collections.dq is there. By using this collections.dq also, we can implement a stack. So it is a predefined module, sir. That's why directly we can work. So if you want to work with this, we have to import from collections from collections. We are going to import DQ. There is a special module is there. So here I am taking stack is equal to, simply we can able to call DQ. So we created a stack. Then we can perform append operation. Suppose consider I am appending 10. So we can append 20, we can append 30, we can append 40, like that we can append. Now if you print the stack, it is going to display so a DQ objects list where the objects will be 20, 30 and then 40, same like list. But technically the name which we have given is DQ. You can see we have 10, 20, 30, 40 is there. Sir, can I get a topmost element? Yes, no problem. You can get. Simply, it is also like a list. You can ask -1. Immediately, it is going to return the element which is available at the top, which is nothing but a 40. Okay. Sir, can I get, can I remove the objects? Yes, you can do that. So how you can able to remove? For this also, we have one normal list function only there. So we can able to take stack.pop operation. So after this, we will try to print a stack. You can see which item is removed. 40. Last item is removed. Like this, we can implement stack by using this DQ also. So we have two options are there. We can go with either list implementation, or second option is what? We can go with this particular DQ operation. Anyone you can use, sir. These are nothing but the two ways, okay, by using predefined methods, how we can able to implement this stack data structure. Can you please confirm? Do you have any doubts up to this?
No, sir.
No, sir.
Right. So now we need to go for implementation, stack implementation. So by using my own methodology, I want to do stack implementation by our own, but here I am going to use list concept only. I will use list concept, but I will prepare some functions. Let us see how we can able to do that. Sir, for this I am going for object oriented terminology. I am taking a class called stack. I am taking a class called stack. In this stack I am performing initialization activity. So you know very well, whenever we are initializing, I am going to take self dot, okay, yes, in the sense stack, sir, or otherwise what we can able to take, okay, let it be yes only, stk I will take stack. I am using the list only for representing this stack. So it is nothing but what? So constructor for initialization activities. For initialization activity, sir, I created a stack with list. That's all. So now what is the first operation? Is empty operation I am trying to implement. So when isEmpty function is going to return true, we know. So empty, it is nothing but taking self as the argument, and I am going to return, okay, so what I am going to return? Length of, so self dot stack is there, right? It is a list. If length of this list is 0, then immediately isEmpty function is going to return true. So now consider I am creating a stack object for this stack class. So after creating, I am trying to call yes dot isEmpty function. What output we are expecting? It will return true because the stack is empty. Just we created one stack. That's all. Sir, now isEmpty function is very clear for us. Now what is the next function is, I want to return the size. So size of the stack, I want to return size of the stack. So def, I will implement a size function which is going to return length of self dot stack. That's all right. Suppose here if you call print s dot size, what is the size of the stack here? We have 0 is there because we don't have any elements. So after this, what is the next operation that we are going to perform? Very, very important operation. I want to display. So print or display or traversing. Sir, what we are going to do? So here just I will use a display function where it is taking self, and I will write it directly here. So print of self dot stack. Okay. Sir, now I am going to print the stack. Yes dot, which function we have to call? Display function we are calling. What output we are going to get? Empty list we will get. Okay. So if you want, you can put a condition. If length is 0, then we can display stack is empty. Something like that we can write the conditions. Okay. So next term, I want to perform push operation. Yes.
In display function, please return one. Please use return statement in display function because you are using print as well, so it will return none as well in the output.
The output.
Yeah, in display function, use return
yeah.
statement. Otherwise, you are using print statement together, then it is
Yes,
returning
yes,
none
yes.
as well.
Yeah, better to call print off like this.
Yes.
That
Or
will
we can
be
use
fine.
return as well in display
Yeah,
function.
yeah. Right. Good. So now which one we are using? Push operation. So I will take the name as a push, self comma. We have to provide the data which you want to push. So since we are implementing by using list concept, so which function we have to use? Self dot stk stack data append of whatever data you have given that I am pushing. And if you take pop operation also, what is a pop operation? So self dot self we are going to give, it is going to return. Okay, I think we should not return anything. Okay, better return. So self dot stack dot pop. So now we will see the corner cases also, don't worry. So now here I am going to push one object. So yes dot push off, let us take, I am taking 111 and then 222. So what output we are expecting? You can see the items are nothing but 111, 222, and we have size as a 2 and is it empty? No, it is not empty. Sir, I will remove this is empty function. Now consider I have empty stack is there. Okay, so now I'm trying to call. Okay, I'm trying to call. So yes dot pop, yes dot pop. We are trying to remove an object. Have you observed? So pop from empty list, index error we are going to get. That's why here I will write a condition. If self dot, already we have one function is there, right? Is empty function is there. So if self dot is empty, then we can raise a error message. We can raise error message. What is that error? Is nothing but runtime error. So where I'm going to stack is underflow, right? It is the condition. Underflow means what? We don't have any elements in the stack. So otherwise it will return stop. Now see what will happen. Stack is underflow, like we are going to get. Sir, I don't want this. Simply I need a message. Then what we can able to do? Just we can print stack is underflow and then return the control. That's all. Now let us see what will happen. If I run the program, you can see it is printing the message saying stack is underflow. We can't delete. Sir, assume already we have some objects are there, like append of 111, append of 222. Now see which item it is going to remove. Sir, here we have to use which function? Push, because we have implemented already, right? That's why. Now you can see what will happen. 311, 322 are pushed into the stack, and the removed element, that is popped element, is nothing but 312. Like this we are getting. Okay, like this we are getting. And after pop, if you are trying to call display function, so you can able to see what items will be there. Have you observed? We have only one element is there in the stack. So this is nothing but how we can able to implement this push function, pop function, display function, all these things. I think you people understood all these operations. And if you see what is the time complexity for these operations, means in the beginning itself, I told in the case of stack and queue, every operation is going to take unit time, big O of 1, because we are not at all writing any loops. We are not at all required to move the control from one place to another place. Okay, so because insertion will be done at last, deletion also will be done at last, peak operation is also going to return the last object. That's why, so almost the time complexity it is going to take is nothing but unit time, sir. Big O of 1 time it will take. I think you people got a very clear clarity about this. Can you please confirm any doubts up to this? Please confirm.
No, sir.
Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Right. This is nothing but implementation of stack by using list concept. Now, sir, we are going for stack implementation. Stack implementation by using linked list. Already we know linked list, right? By using this linked list also, we can develop a stack. Let us see how we can able to do that. Sir, can I use the same functions? Yes, there is no change at all. Same functions only we have to use. Now see, stack I am taking like this. But if I want to work with the stack, I think we need one more class. So we know very well I am creating a class called node. In this node class, I am defining a constructor. Inside this, whenever you are creating a node, you are going to pass two fields. One is a data field, another one is nothing but next field. Suppose if you are not passing any next field, it is nothing but none. So self dot data is equal to the data which you are giving, and self dot next field will become So next, whatever you have given. This is nothing but linked list, sir. Single linked list I am taking. Then inside the constructor, so don't create a stack because we are going to use our own representation. We need to maintain one pointer, which is nothing but a head. What is the default value of head? It is nothing but none. And try to maintain a separate variable called size. Already size variable is there, right? Better to go for count. What is the default value of count? It is nothing but 0. Coming to isEmpty operation, if it is isEmpty, when it is going to return isEmpty, so we are going to check self dot count. If self dot count is equal to 0, then we can say it is nothing but empty list. Now, sir, I want to get the topmost element. I think we forgot to implement this. So peak operation in the sense we have to return the element present at the top. It is taking self. So if self dot is empty, if your stack is empty, simply I'm going to raise a message saying, so stack is empty or underflow condition. Simply we are going to return the control. Okay, simply we are going to return the control. Otherwise, what we are going to do, we are going to return self dot head dot data. Okay, so here head is nothing but a special pointer which will be always maintained at the top. Okay, so that pointer it is going to return. Consider, sir, here I am going to represent a stack data structure by using linked list. So initially what will happen, we created one special pointer called head. That pointer is always pointing at none, and the number of elements present in the linked list is nothing but 0. That is a stack. Now consider we have to perform insert operation. So insert operation skeleton is already there, right? What is that? Is it a push operation or not? Yes. We have to write code for pushing the data. Let us see how we can able to perform this push operation. Sir, how to do that? We are going to create self dot. We are going to create a self dot head is equal to, so self dot, we are going to create a new node. So with the given data, and the next pointer will become self dot head. This is the way, sir, how we can able to create. Then after creating, your count will become, so self dot count plus 1. See how it is going to work. Please listen carefully, friends. What is the initial value of head? Initially, the head value is pointing to none. Now I want to create one new node. Sir, what I am going to do? This is nothing but my new node. I am going to call this new node function. So by taking data. So data is nothing but what? Assume it is nothing but a 10. What is the default field for next? It is none. But what I have given self dot head. So what is the head pointer is pointing? None. So this will become a node, sir. And what is the name of this particular node? So head. This is nothing but the name of the node what I have given. You can see in the diagram. So self dot head is equal to, we created a new node and we attached that node as a self head. Now we have to increment the count by 1. Sir, first object got inserted. Now I want to insert one more object. Sir, how we can able to insert one more object? Very simple, sir. I am going to create a new node. I am going to create a new node with content 20. What about next field, sir? Have you observed self dot head? So self dot head means what? This one. Can I say a link will be established like this or not? Yes. Now if you are asking who is the next field to A, means this one. Now automatically your head will be moved to this position or not? Yes. Now I want to insert one more object. No problem, it will be created. Assume the data is nothing but 30. What is the next field for this node? It is nothing but a head. Now after this reference will we are assigning to head. Automatically your head will become like this. Like this, it is keep on performing insert operation. Can you please confirm everyone? Is this a push operation? Is it clear for you people? Please confirm.
Yes, sir.
Yes, sir.
Yes, sir.
Right. Now I want to perform delete operation. So how you can able to do delete operation? Delete operation means what, sir? We have to remove one entry from the stack. So let us see how we are going to do that. If a stack is empty, then we are going to return underflow. Otherwise, let us take the value which is available in the head. So self dot head dot data I'm taking. That means which value is going to be deleted, that I have taken. So after that, what I'm going to do, I'm going to check self dot head will become, so self dot head dot next. So what is the next node to head? 20. That 20 will become now head node, sir. So immediately we are making this particular node to this one. So once if you change the link, sir, have a look once. This node reference is not there. Automatically, is it eligible for garbage collector or not? Yes. But we copied the previous node content, right? That we can able to return at the ending. This is nothing but what we have, pop operation. Now, sir, display operation. I want to display the elements present in the list. How I can do? We have to maintain one temporary or current node, which is always pointing at a head. So until your temporary node is not equal to none, so what we are going to do? We have to print the objects one by one. So I am taking temp dot data, and your end will become something like a space. Okay. So after that, so temp will become temp dot next. Temp will become temp dot next. Once if you come out from this, I am printing empty. This is nothing but a display operation. Definitely it is going to take, what is the time complexity for this? Big O of 1, because we need to write n values. Okay. This is nothing but what. And coming to this peak operation, so self dot is empty. It is going to check whether it is empty or not. Otherwise, we are going to return self dot head dot data. So head is pointing at 20, right? That element it is going to return. This is the way, sir, how it is going to perform peak operation. So I think all the operations we implemented, right? Constructor, is empty, peak operation, size operation, display operation, push operation, pop operation, all these things we implemented. Let us run the code. Sir, I'm creating S is equal to, I created a new stack. Then I'm trying to display. So I think in the display, we have not written corner case, right? Let me write. So when it will be, suppose if your stack is empty, so I'm going to print list is empty. And simply I'm going to return the control. Now let us call display function, sir. Yes dot, I'm calling display. You can able to see the output. What we are going to get is empty is not defined. So since it is there inside the class, we have to call by using self keyword. You can see the list is empty. We don't have any elements in this list. So yes dot push. Now I'm going to push 100. I'm going to push 200. I'm going to push 300. Three objects I inserted. You can see, so 300, 200, 100. But of course, it is returning in this format. Even if you are trying to delete which item it is going to remove first, so 300 it is going to return. So let us consider yes dot pop I am taking. So which object it is going to be deleted? You can see 300 is the deleted. So after performing this delete operation, let us call display function. Now you can see the objects what we have is 200 and then 100. Okay. Suppose if you are calling peak function, which item it is going to return? The topmost element it is going to return. Sir, I want to check how many objects are there. Yes dot, can I call size function? Yes, which is going to return. So how many objects are there? 1 second. I think size we have not implemented. I think so. Yeah, here we have to return. Can I say self dot count? And whenever we are popping, is the object got deleted or not? Yes, we have not performed that delete operation. I am taking self dot count will become, so self dot count -1. Now let us see. Sir, we have only two objects are there. Like this, we can implement this stack data structure by using linked list concept. I think both the concepts are very clear for you, like how to implement this stack by using list concept, by using predefined list, by using DQ, by using our own, but internally we are using list, and our own implementation by using linked list. Is the four implementations of this particular stack. Is it clear for you people?
Yes, sir.
Yes, sir.
Sir, is it possible to print 10 without printing before 20, sir? If you want to print self dot, head dot, next dot data, it will print 10. Here, sir. 200 will print before the 200 also. It is possible, sir.
You can store it in a separate data structure. I mean, separate list or something like that, and you can print. But in which order it is printing is not required, right? But if I use a recursion implementation for printing these items, then it will be printing in the reverse order. So that is not an issue because no one is going to ask how many, I mean, what are the elements that are available here. See, that is the main difference. In our array or linked list or anywhere, you are traversing from left to right. But a stack follows which technique? Last in, first out. The item which you have inserted the last, so that item you are going to get first. Display function, don't put more concentration, sir. If you want, you can display in the reverse order also. If you implement by using recursion, you can do that.
My query is as a stack rules, we can't print first in, first in, last out manner, sir. So in this code, we print 100 before 200, sir. Is it possible, sir? Yes, correct,
How
sir.
it is possible?
Self dot, head dot, next dot data. Print.
See, here we have 3 elements. That's why you are asking head dot next dot next. If you have 100 elements, Saikiran, don't get confused. See, 300 is the topmost element. Is it correct?
Yes, sir.
That should be printed first. What is the next element to 300?
200, sir.
That's all. What is the next element to 200?
100.
Yes, like this only it will print. Why 100 will come in the beginning or middle?
We want to print manually, it is possible, sir.
Why we will print? What is the need? It is not a list data structure, right? It is a stack. A stack means in this order only we created the links.
So we can in code also we can do that exception.
Why,
sir?
sir? I am telling why we have to do. Because it is a stack data structure. The item which is available, you are telling, suppose if you have a stack of plates, you are trying to remove in the middle. What will happen? Entire plates are going to be collapsed, right?
Yes, sir. Yes, sir.
Then you should not follow that. Don't see display functions. Display function will always based on our requirement.
Okay.
Clear?
Yes, sir. Yes, sir.
Right. Don't concentrate on this. Try to see the functions.
Sir,
Yes.
is modification of element is allowed in stack or not?
Modification of
Modification of data in between data.
whatever operation that you have to do on the stack, you should be performed only at the top.
Okay, so we can only modify the topmost element only.
Yes,
not-
yes.
Okay.
See, this stack, actually what is the purpose of stack data structure is just, it is a container to holding the objects. Someone is there. If you are giving object to them, they will hold that object. Again, whenever you ask, they will return the object. That's all. No other operation we have to perform on stack because it is a container which is going to follow LIFO technique. If you give an object, which object latest you have given, that object they are going to return first.
Yeah, got the
So
concept. Sir.
taking that object and you can do your own operations. In your hand, you have to do. You can't do that operations on the stack.
But linked list also stores in stacks, sir, or any other memory?
See, you people are getting confusion. If I am explaining this linked list concept, I told very clearly, linked list is not a continuation memory location, but we are making it as a continuation memory location by using the links. Got it? Suppose if the one object is available in the Delhi, another object is available in the Hyderabad, means we will create a link from Delhi to Hyderabad. That is called as a linked list. Got it? So that link is the main concept in the linked list. But we are using list means continuation memory location will be there. Like a 10, if you are trying to insert a 20, 10 and 20 will be allocated in the continuation memory location.
Yes, sir, but internally it uses stack, right? Whatever it may be, recursion, backtracking, or whatever it may be, stores in stack.
Which one, sir?
Linked list or whatever it may be, stack is a temporary memory, right? Or
Sir, stack is not a memory, sir. It is a data structure.
okay.
So stack is not a memory. It is a data structure. But some people are going to use the stack everywhere. That's why you are
Then
getting
How
confusion.
we are storing one
So
data?
why you are using stack in the sense, because in the method calls, so that stack data structure they are using internally. In the recursion they are using stack data structure internally. So even everywhere, suppose in your home, if you want to arrange the books in a rack, you are going to follow stack data structure. So that is the reason people are going to use the word called stack in the real time very often. That's why you are getting confusion. It is a data structure. Linked list is a different, stack is a different. The technique you have to observe. So the
So
technique is what? Last in, first out. Some people may have a doubt, sir, can't we convert linked list into a stack? Yes, you can do. In the linked list, we performed so many operations. Take that linked list and restrict all the operations and allow only insertion at the ending, deletion at the ending. Then it will become stack or not?
Okay, so stack is not memory. I think
Stack is not a memory. Stack
Yes,
is
sir.
not a memory.
So
It
it's
is a data
organized
structure.
How
Yes,
we are
yes.
using one data structure in another data structure then? We just did for list and linked list.
Sir, can you please repeat? Speak
Sir,
louder.
We are using one data structure inside another data structure. We just use list it and then linked list.
We can
Sir.
use, no problem. What is the reason? What is the delay? I mean, what is the problem with that?
Then what is the purpose of list and linked list, sir? If stack is there.
No. List is nothing but it is a similar to linked list. But list is the facility which is provided by Python. In other programming languages, we don't have any list concept. Okay.
Sir, what about linked list?
Linked list means what? Insertions, deletions, so updations, everything is possible at any location. That is linked list. Same operation we can do in the list also. But list is the predefined collection which we have in Python. But in other programming languages, we don't have list. But their linked list concept is required, right? So linked list is a data structure. Because we are learning with the help of Python, that's why it seems to be list and linked list both are same. Yes, of course, both are same. But list is the predefined concept. Linked list is nothing but we are going to create. Got it? Create an empty list and display function. Yeah, we can do that. Sir, is the implementations of these stack data structure in all these 4 ways are clear for you people?
Yes, sir.
Yes, sir.
No doubts, right?
Yes, sir.
No, no.
So, right. Sir, for understanding purpose, for easy understanding purpose, I am taking one small applications. Directly, I am moving for applications of stacks. Listen carefully. What is the first application is, sir, majority of students are having doubt. That's why I'm covering this topic. Sir, system stack and function calls. How this system stack is maintained, how the function calls are going to be work. I will explain with the help of a simple example. Please listen carefully. Consider I have function 1 is there, which is not taking any arguments. Otherwise, let me take function 2 first. So here I am going to print, so a message saying, so function 2, line number 1, like this I am taking. Now I am going to define function 1. This function 1 is having a message like a function 1. So line number 1, line number 1. Then I am calling function 2. Then I am going to take, so function 1, line number 2, like this I am taking. So then I am going to call main function. Inside the main function, I am taking main line number 1, main line number 1. Okay. So then I am going to take a function 1 I am calling. Then I'm going to print, so main line number 2, like this I define. Sir, now we have to find out what is the output of this particular program. Sir, listen carefully how it is going to work. So internally it will maintain a stack, a system call or not? Yes, definitely it is going to maintain a stack. Sir, how it is going to be executed? In the stack, multiple entries will be there. It is a open stack, one side open. Sir, now what will happen? First, the program execution is going to start from main. I will call main function. What is the output that I am going to guess here is, listen carefully. First, I called main. Main program is started. So execution, it is printing. So main line number 1. Okay, main line number 1. Anyway, that entry will be there inside the stack. So we called which function first? Main function we called. And what is the output that we are going to display? So main line number 1. It is going to call like this. Then what will happen? Immediately it encountered function 1. The control will go to the function 1, sir. The control will go to the function 1. Corresponding entry they are going to maintain. Since it is a new call, right? That function 1 is going to be called. So inside this function 1, we are calling, we are printing function 1 line number 1. That is nothing but next line what we are going to get. Then again what we are doing, we are calling another function. The control will go from here to top. Then again what will happen? Sir, one more entry will be maintained in the function. Now what is the content in this function to line number 1? It is going to call. So it will print function to line number 1. So actually the method calls got completed. Total method calls got completed. So okay, program execution completed. Now what will happen? My Python is going to identify what is the latest method that you have called function 2. So is there any pending instructions here? No, all the instructions got executed. So try to delete this entry from the stack. Try to delete this entry from the stack. Sir, it is deleted. Then what is the next entry? Function 2. Can you please cross check in function 2? Do we have any function calls are pending? Yes, this second function call is not executed. Now try to execute that. So function 1 line number 2 got executed. Sir, after this what we are going to do? So we have to delete that function call also from the stack because it is completed. Then come to main method. Is there any pending instructions are there? Yes, one instruction is there. So then what will happen? That instruction is going to be executed. Okay, that instruction is going to be executed, which is nothing but line number 1. Sorry, line number 2. Sir, this main function is also completed, right? After doing this, what will happen? Sir, my system is going to destroy this total stack, sir. This is nothing but internally happen. Sir, here it is one of the application who is responsible to create this stack, means system is responsible. In all the functional oriented programming concept, system is going to maintain these kind of things, sir. I think you people understood very clearly. Any doubt? Let me execute this code, sir. First we have to see the output whether it is correct or not. Have a look once. Main line number 1, function 1 line number 1, then function 2 line number 1, then function 1 line number 2, then main line number. Sir, can you please confirm how these function calls are maintained? Is the concept is clear?
Yes, sir.
Yes, sir.
I request everyone to please confirm. Clear up to this?
Yes.
Yeah, Mukesh, can you please switch off your video mode?
Please,
Sir, clear, please respond.
Yes, sir. Yes, sir.
Sir, clear, sir.
Right. Right. Sir, just I want to give some 2 minutes break, 2 or 5 minutes break. After that, we will see some functionalities. So just I will give break for 5 minutes. After that, we will continue. Okay. Yeah, so welcome back. Can you please confirm, am I audible? Is my voice is clear? Sir, am I audible?
Yes,
Is
sir.
my voice is clear?
Yes, sir, clear.
Right.
Yes, sir, clear.
Good. So now here the next one, we have seen one application. Now I want to maintain a stack. Okay, I want to maintain a stack which is used to hold student objects. Okay, I want to maintain a stack to hold student objects. Okay, let us see how you can able to do. So stack to maintain student objects. Sir, I have some student objects are there. I want to maintain these student objects inside a stack. Okay, so how we can able to do that? Consider I'm going to take a class called student. Okay, student class is there. At the time of creating this student object, I will provide some information like I'm going to give student ID and then student name. These two attributes I'm going to give, and self dot student ID will become student ID. So self dot student name will become student name. Like this, I'm providing some two informations. This is nothing but a student class one. Sir, now I want to store this information inside a class. How you can able to hold? Sir, already we have stack class is there, right? So what I will do is, already it is implemented by using linked list. Better I will take this one only. Let us try. So I'm creating a new Python program. I'm creating a new Python program. So I'm giving this Python program name as a stack.py. So I have the total stack is available. So I'm going to import that stack to my program. So then what we are creating, stack s is equal to, I'm creating a new stack, and s dot first I'm going to call display function. Let us cross check. So module object is not callable. Better I will use, so from stack import star. We are going to import all the functionalities. Now have a look once. So we are going to get my list is empty, that is a stack is empty. Now I want to create some student objects and I want to push into this stack. So let us take first student object I am taking. Let us take the ID as a 111 and the name is nothing but a 388. Like I'm creating some 4 student objects. Let it be 222. So 333. So 344, and here I'm going to take 3BB, and here I'm going to take 3C and then 3D. Like this object is nothing but a second student, third student, fourth student. Now I'm going to push these objects. So yes dot push off. Can I push first object? Yes. After this call, what we are getting, sir, it is returning the student object in this format. But I don't want this. I want a student name under that hall ticket number, ID number to be displayed. So we have to override which method? Anyone remember?
Underscore underscore str underscore
Yeah.
underscore.
Yes. In which class we have to implement, in the stack class or student class?
Class.
Yes, in the student class, we have to override which method? Underscore underscore str. So which is going to return in a string format. What data we are going to return? So I will take the student details within these square brackets. Otherwise, let us put it within this parenthesis. So I need first student ID, student ID. Okay. So then after this, I'm going to take self dot student name. Like I'm going to hold these two values. Now see what will happen. Is it displaying the first student information or not? Yes. Now I'm trying to push second student details. Now if you print second student details also came. Now I'm trying to store third student. Sir, third student details also came. So I'm trying to fold fourth student. So all these 4 student details are added into the stack. So if you perform removal operation, which item it is going to remove, we know very well. Yes dot pop, if you perform, sir, it is going to return 444 object. This is nothing but what we have. Okay. So if you print this pop inside this, then it is going to return the object which is removed. The object which is removed is nothing but 444. So like we are taking a stack class to hold student objects and just we are printing. Sir, for all these things, we need stack class. I created this stack class in the form of a mod, like a stack.py. So I created my stack. On this, I am going to perform. These are the operations. Can you please confirm how it is maintained? Is it clear?
Yes, sir.
Yes, sir, clear.
Right. So the next operation. So the next operation, I want to do sorted insertion, sir. Sorted insertion into stack. Of course, it is not possible, but with the help of some technical logic, we are going to write. Sorted insertion in the sense what? When you are trying to perform insert operation, generally how the insertion is going to be performed, we know. For example, consider I have a stack S is there. I want to push some objects into this. Like let us take S dot, we have to call push function 4. Then I am trying to call 1. So then I am trying to push 3. Then I am trying to push 5. Then I am trying to push 5. So what will be our output here? You can see. So 2 is the latest inserted element, and then 5, and then 3. Like this we are getting. So I don't want this. I want to push according to sorted insertion. So I want to call this push function. So I will call sorted insertion. Sorted insert function. I will give the stack and then I am going to give 4. Now what will happen? This 4 has to be inserted into the stack by using sorted insertion technique. Let us see. I will define my own function sorted insert, which is going to take a stack and then which data you want to insert. Okay, which data you want to insert. Sir, how we are going to check? We will check whether your stack is empty or not. If your stack is empty or the value which you have given is greater than stack.peak. If it is greater than that element, then simply try to push that object into the stack. Sir, let us see what will happen. Assume internally I have a stack like this. So first time I am trying to insert the item called 4. Now cross check. Sir, is stack is empty? Yes, my stack is empty. Directly we can push because we don't have any other objects. Directly we can push. Now assume I want to insert a 5. Now you can see, is stack is empty? No. And the data which you are trying to insert, is it greater than the topmost element? Yes. That means you have to insert this particular stack. Sir, have you observed these two are arranged in a proper order or not? Yes. This is nothing but the condition. Suppose consider the data which I want to insert is 1. So is my stack is empty? No. Is the data is greater than the topmost element? No. Then 1 is not has to be inserted here. 1 should be there at the bottom. Okay. So then what we are going to do? Suppose if this condition is not satisfied, then temp is equal to, I'm going to pop the item from the stack. I'm going to pop the item from the stack. Please listen carefully. So now your temp is going to hold which value, sir? Yes dot pop. We have popped 5. So 5 is removed from the stack. That value is available in the temp. So after this, what we are going to do is, so I'm taking sorted insert function. Again, I'm calling by passing the same stack and then data. So what will happen? What is the data, sir, here? The data is nothing but 1. With this, again, we are going to call. Is stack is empty? No. So what is the data that we have? 1. Is it greater than peak element 4? No. Condition is not satisfied. Now, sir, temp is going to hold the value called s dot pop, which is nothing but 4. Again, we are calling sorted inserter function. So by passing s dot data. Now you can able to see, is my stack is empty? Yes. Then try to push that object. Which object it is going to be inserted, sir? 1. Sir, up to this, okay. But where is the remaining content? Sir, where is the remaining content? You can see, since we are using stack, these two values will be stored in the method calls or not? Yes. So how to insert this? After this recursion. So can I call s dot push off that temp? Because first time we popped 5, second time we popped 4. Which is the latest one? 4, right? That 4 will be pushed into the stack. This entry will be deleted. Then one more temp is there, that value also pushed into the stack. This entry will be deleted. Like this it will store. So let me cross check. First we inserted 4, then we are trying to insert 5, then we are trying to insert 1. Sir, is these objects are stored according to the order or not? Yes, 5, 4, 1. Okay, so this is nothing but a sorted insertion what we have. Now let me try by pushing 2, and let me try by pushing 3 and 6. Let us see all these elements are arranged in a ascending order or not. Yes, in the stacks, I am telling, the topmost element is a 6 and remaining elements as usual we have. Can you please confirm? So how we have performed this operation? Is it clear for you people, sir?
Yes, sir.
Yes, sir.
Yes, sir.
So I think it is very easy code. I request everyone to please confirm how we have performed this sorted insertion. Is it clear?
Yes, sir. Clear, sir.
This is the way how we can able to do sorted insertion. Sir, my next operation is nothing but I want to sort the stack elements. Sorting stack elements. I want to perform sorting of stack elements. Already I have stack is there. So we have to perform sorting operation on this. How we can able to do? For example, consider I am removing this, listen carefully. So yes dot, so push off, yes dot push off, I am taking 444, yes dot push off 111, yes dot push off 222. So yes dot push off 333 and yes dot push off 666 and yes dot push off 555. Like this, I have some entries are there. So is the stack is having sorting order? No. Now I have to sort this data, sir. How to do that? How to do that? Just here, I am calling a function called sort stack. Sort stack. Just I will pass that stack as the argument. So this sort function, sort stack function is a utility function which is going to sort the stack. Sir, let us see how it is going to work. DEF sort stack function I am taking, where it is going to receive one stack. And here also we are going to check, is my stack is empty or not. If your stack is empty, okay, then we have to stop the process, or we have to empty is going to return true if your stack is empty. Okay, here it is not empty. Then we are going to store the topmost element inside this temp, and we are going to call sort stack again by passing yes. Sir, have a look once how it is going to work.
Sir,
Consider the objects what we have here
sir,
is
you are doing this when it is empty.
when it is not empty. Okay, 1 second. I will rewrite the condition.
It
So
is
what is
empty.
yeah. You can see here, sir, first item we have inserted is 444. So then next item is nothing but a 111. So next item is nothing but a 222. So next item is nothing but a 333. So next item is nothing but a 666. Next item is nothing but a 555. Like this, we have some elements are there in the stack. right? Sir, now we are going to see how it is going to work. Is my stack is empty? No, it is not empty, right? So I think we have to take a note of this.
No, yes, sir, not of this we need to take.
So now we are going to get the item. What is the item that we are going to get? Since it is not empty, is empty is going to return false. Yes. So we are going to hold temporary is equal to yes dot pop. Sir, we popped one item 355 from the stack. Sir, it will be maintained internally inside the system call or not? Yes. Sir, now second time, if you observe, again we are calling sorted stack by passing the same yes. Is my stack is empty? No. Then second time, your temporary value will become 666. Then automatically that value will be deleted. Sir, again it is going to be called, your temporary value will become 333 and we are going to make stack as a empty. So then we are going to copy the next value 322 and we are going to delete those entry from the stack. Again, we are going to delete the one more item called 311 and at last we are going to delete 344. Sir, after doing this, what will happen? Sir, my stack is empty. Yes, the condition is going to be false. Sir, if I am writing any instruction here, is it backtracking, right? Means what? It is going to do in the reverse process. Sir, in the reverse process, I am going to call a function called sorted insertion by passing yes comma temp. Now see, what is the first last latest item in this direction? 344 is the latest data. Sir, try to insert inside the stack by using sorted insertion. So 344 will be inserted here. That entry will be deleted from the stack frame. So we are using two stacks internally. Sir, next item is 344, sorted insertion. So sorted insertion means what? Again, it will use one more stack. 344 will be hold here and 311 will be hold here. Next, we are trying to delete this and we are calling 322. Sir, what will happen? That 344 will be removed and 322 will be stored here and 344 will be available here. Next, we are trying to insert 333. Sir, what will happen? This entry will be deleted and 333 will be inserted in this position and then 344 will come here. So then we have 666 is there. So this will be deleted and here 666 will be stored. No. So 344 will be there and 666 will be stored here. So then this entry also will be deleted. Now what will happen? So this 666 here it will come and 555 will be come here. Like this, the total list is going to be sorted. If I am wrong, just have a look once how it is going to work. Is the data is going to be sorted or not? Yes. Before performing sorting operation, this is the content. After performing sorting operation, this is the content what we have. So can you please confirm, is a sorted insertion and sorting the stack by using these utility methods? Is it clear for you people?
Yes, sir, it is clear, sir. I have a doubt. Like this
Yes.
program will be terminated when stack is empty. Like last
Yes, sir.
program call will be terminated when stack is
Yes.
empty.
Yes, yes, sir.
Okay, so that is a base condition as well.
Oh yeah, base condition as well. So
Okay.
because we are doing modifications on the list, right? We are doing modifications on the stack. So if you are giving a full-fledged stack and inside that the operation which we are using is deletion. So
Yeah.
definitely it leads to infinite calls. So at one situation it will become empty. Then I'm going to stop.
Okay. Okay.
So
Yes.
after that, this is the operation that we are going to do.
Got it, sir.
Actually, it is not possible to sort the data inside the stack. So because we have only one pointer is there, right? But by using recursion, just we are using the manipulations. Okay.
Yes, it's clear, sir. Got it.
Right. Sir, that's all about this today's session. Actually, continuation is there for this stack. Still, we have few more operations are there. Like we are going to see bottom insert. Suppose if I want to insert the value at the bottom, how we are going to do? So reversing the stack. Suppose I have stack elements are there. I want to perform reverse operation. How you can do, and even balancing the parenthesis. If you have a parenthesis is there, how to balance that parenthesis. Next and after that, So infix to, okay, infix to prefix conversion and infix to postfix conversion is there. Next, and after that, evaluation of so prefix and evaluation of a postfix. These things are there that I will cover in the next coming classes. Okay. And
Sir.
don't delete this link, sir. Please save this link because we are going to plan 2 more sessions on weekends. But whether it is the same timings or not, I will inform you later. But you have to use whenever I'm telling extra class, you need to attend by using this link. That's why don't delete this link. Please preserve this link. Okay.
Okay, sir. Sir, means in the interview, what they will ask, either custom stack or inbuilt?
If they are asking inbuilt, I mean, if they are asking applications like this, you can take the help of inbuilt and you can solve. Suppose
Okay,
if
sir.
they were asked implement a stack to perform push operation, implement your own method, then you have to write your own code.
Okay, sir. Okay.
Right. So thank you. And these running notes will be shared for you separately in your respective batches. And even the video also we are going to share in the respective batches. Okay. So that will be
Sir.
given, sir.
Sir, when will this course ended, sir? This course, when will it completed, sir? Approximately.
Maximum next month, first week.
Okay, sir. Because of next month 10th, I have semi examinations.
Maximum before that only it will be finished.
Sir,
Hmm.
sir, please include bit manipulation and greedy as well, because I have a lot of issues in that.
Yeah, okay, sir. We will see.
Sir, how
Sir,
long the videos
sir,
will be?
after
Videos will be available with 6 months access from the start of your registration.
Okay. Sir.
So you are saying 6 month and Durga Soft is saying 8 month.
Who told?
Actually, team told, sir, backend team. Actually, sir, if now
If
2
it
months
is,
is
if it is 8 months, then no problem.
no, sir. Now your means our teaching, you teach for 2 months, 2.5 months, right? So we have only 3 months access.
Yes, that's all. After completion of course, you will start reading, or while classes are going on, we are starting revising. Huh?
After class.
Once if the class is completed, what is the purpose of video? Whenever you have time, you have to refer, or continuously you have to refer.
Notes. Notes.
Yes, you have to watch the
some
videos
doubts
in
and
the same week. Yeah. So that's why we will start from the beginning. Okay.
Okay, sir.
Right. Generally, validation will be starting from the date of registration. Not only this course, sir. Anywhere, if you take any scenario, the start of registration is the starting date, and from that they will count. Okay.
Okay, sir.
Right.
Sir,
So
after
thank you.
course completion, please tell us something interview questions and regarding this.
Yeah, we will.
So at the end, sir, at the end of this batch,
Yeah.
you can miss.
If time
Sir,
permits,
any-
definitely, sir. Otherwise, we will conduct one free workshop for interview questions. There I will discuss. Okay.
Any
Okay, sir.
certification, sir? Certification.
Certification, you can contact our team. They will provide course completion certificate after completion of this course, not now.
Okay.
Right. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.